ở đây mà ngứa, khô, nấm candida, hôi tanh vô cùng. Dùng ngay cho em, đảm bảo hiệu quả ngay sau 3 đến 7 ngày sử dụng. Em Nga hiện là tổng giám đốc công ty đang hợp tác với rất nhiều các chuyên gia đầu ngành cả Đông y và Tây y về vấn đề phụ khoa phụ nữ để mang đến cho chị em bộ 3 sản phẩm An Phụ Phùng Da đang được đông đảo chị em săn lùng. Bộ 3 chăm sóc phụ khoa An Phụ Phùng Da nhà em Nga được chị em phản hồi rất hiệu quả. 10 người sử dụng thì 10 người đều hài lòng. Hơn nữa, em Việt Nga lấy uy tín của mình cam kết sử dụng sản phẩm của em tuyệt đối an toàn, lành tính, tiết kiệm, không phải đốt, cực kỳ dễ dàng và đơn giản. Cô bé của chị em sẽ sạch sẽ, thơm tho, hết ngứa rát ngay lần đầu tiên sử dụng. Khi mua combo An Phụ Phùng Da sử dụng, chị em sẽ có ngay bộ 3 sản phẩm gồm dung dịch rửa, bút keo và lọ cao uống. Sử dụng cực kỳ đơn giản dễ dàng. Đầu tiên, lọ dung dịch vệ sinh chị em xịt ra lòng bàn tay, xoa nhẹ, massage vùng cô bé 1 đến 2 phút, sau đó rửa lại bằng nước sạch. Cái này dùng được cho cả nam và nữ nha. Sau khi rửa xong, bước 2 chị em dùng đến bút keo này, đưa sâu vào vùng trong cô bé từ 4 đến 5 cm và đẩy gel vào bên trong. Mọi người có thể quan hệ sau 45 phút sử dụng. Cuối cùng là 2 thìa cà phê cao uống bổ sung 1 ngày 2 lần sẽ giúp tăng cường nội tiết tố, cân bằng độ pH, ngăn trừ viêm nhiễm, tăng tiết dịch đạo độ ẩm cho cô bé. Bộ 3 chăm sóc phụ khoa An Phụ Phùng Da lên đến 33 loại thảo dược thiên nhiên, hoàn toàn thuần chay, công thức độc quyền chỉ có em Nga có, chiết xuất tạo ra dòng kháng sinh tự nhiên, giúp xử lý viêm nhiễm vùng kín cực kỳ tốt, gấp 3 lần các sản phẩm thông thường mà không gây kích ứng hay bất kỳ tác dụng phụ nào. Chị em ai muốn mua hàng chính hãng từ nhà sản xuất, không lo vấn đề về hàng giả, hàng nhái, mua hàng với giá ưu đãi nhất thì để lại số điện thoại hoặc gọi ngay cho em Nga. Nhanh tay lên, số lượng có hạn. Em bán cho hàng triệu khách hàng phụ khoa nên quá là uy tín rồi. Em phải nói lại cho chị em, đây là sản phẩm thảo dược thiên nhiên thuần chay, quá tốt luôn, không bao giờ phải lo lắng tác dụng phụ hay kích ứng gì, dùng xong không bao giờ bị khô. Chị em mua váy mua áo đã hết tiền triệu rồi, bỏ ra vài trăm nghìn để cho cô bé thông thoáng sạch sẽ, hết viêm nhiễm, ngứa rát thì còn chần chừ gì nữa ạ. Ai ở đây mà nấm ngứa, khô, nấm candida, hôi tanh vô cùng, dùng ngay cho em, đảm bảo hiệu quả ngay 3 đến 7 ngày sử dụng. Các tình yêu chỉ cần để lại số điện thoại hoặc gọi ngay cho em để nhận tư vấn trực tiếp nhé. Với cơ chế tác động trực tiếp và gián tiếp sẽ giúp tái tạo lại vùng niêm mạc âm đạo, giúp da vùng âm đạo lành trở lại, khỏe mạnh bình thường. Phòng còn hơn chữa, để ngăn ngừa tái lại chị em nên duy trì sử dụng tối thiểu 3 tháng. Đặc biệt là cao uống và dung dịch rửa sẽ luôn tạo ra môi trường vùng cô bé cân bằng độ pH và sạch sẽ, ngăn ngừa hoàn toàn vi khuẩn và nấm. Em Việt Nga khẳng định uy tín, chất lượng của sản phẩm thì nhất định là chị em không được bỏ qua bí kíp này nha. Chắc chắn sẽ giúp chị em lấy lại sự tự tin.
The dust collection that came with my CNC router. So I built a new one and maybe, just maybe, I went a bit too far because now it's full automatic. And it moves completely independent of the Z-axis. And that allows it to permanently stay on top of the workpiece surface. And that greatly improves the dust collection performance. It has a removable brush, which is indexed and held in place by magnets. The hose can be removed and is also held in place by magnets. And it's on the side where it's out of the way for the quick tool changer spindle, where I now have enough space to also install the longest bits I have. For bit cooling and even more improved dust collection, I integrated compressed air nozzles. The whole thing moves on 2 linear rails and is driven by a stepper motor as the 4th axis. The intended use for the 4th axis is for the rotary axis, but since I don't have one, why not use it for automatic dust collection? Now that it's done, I see this whole thing as an engineering project on easy mode. And in this video I want to show you why and how I did everything of that from start to finish. First of all, why did I want to make this upgrade? This dust chute that came with the machine gets the job done, but there are a few major issues and limitations with this kind of design. First of all, it's made for a shop vac hose size. Now I can totally understand why they chose that size, because looking at it from a business or selling perspective, it only makes sense to offer a part size that everybody can use, and everybody with a workshop has some kind of shop vac. And not too many people have a dust collector with a big hose. But looking at it from a technical perspective, a dust collector makes much more sense than a shop vac. This example shows how close you have to get with the shop vac hose and the small dust collector diameter to pick up the dust. The bigger hose can pick it up earlier. The difference there wasn't all that impressive, but usually when it's used during cutting, the chips are not laying on the machine bed, they are in the air. And the dust collector sucks the chips out of the air. So let's test how that performs with the bigger hose.
This example shows the distance out of which the dust can be sucked out of the air.
This showed pretty clearly that a dust collector is much better at sucking dust out of the air because it just has lots of airflow. It moves a lot of air with dust in it. And with this machine being stationary and lots of space around it where you could attach such a big hose, makes it the logical choice for this application. The next big issue is I don't understand why pretty much every CNC manufacturer attaches the dust shoe to the spindle, or basically the Z-axis. It moves together. And that's such a big problem. I have a bit installed right now and it's only this long. And I have adjusted this dust shoe to be all the way up. Now when I attach the bristles, which really make the dust collection effective, they are longer than the bit. Then when you're plunging into the material, all the bristles have to be squished together. And that puts a lot of force onto the Z-axis, which wouldn't be necessary. Same happens then when you move and all the bristles pointing in one direction, but when you change direction, they all have to be oriented in the other direction. And that again puts a lot of force onto the Z-axis. Let's try that on a bathroom scale without the bit, of course. 2.5 kilos isn't actually that bad, and that's because they used relatively thin and wavy bristles, which are quite easy to compress. But that, on the other hand, makes the bristles pretty quickly a mess like this. And chips really get caught in this, and you have to clean that constantly, which is quite a pain. Let's do the same test with my old CNC dust shoe brush, which has straight and more organized bristles. This peaked at almost 5 kilos. And the other thing, you can see the brush rotates because that seems to be the path of least resistance. But in reality, it is kept straight. And I repeat the test with keeping the brush straight with this clamp. And now this peaks out at about 10 kilos. And 10 kilos is a lot, and that's only the force straight up. As you could see before, there are also twisting forces and sideward forces and whatnot. All additional unnecessary loads to the machine. Another issue is with long bits like this one, and you need to plunge really deeply into your workpiece, that there's the risk that you crash the brush into your workpiece when the machine is plunging. So this needs to be high enough. But then again, when it's high up and the bit is not plunging really deeply, then the brushes are not touching the workpiece surface. And then the whole dust collection is basically useless. And the last issue I have that really showed when I was making parts for this project that had a lot of tool changes. This machine is equipped with a nice quick tool changer spindle, but to do a tool change I always have to remove the brush and the hose because both of them are in the way to reach the tool. It seems like a minor issue, but when I was making parts for this project that had like 5 tool changes, this got really annoying. Alright, these are all the issues I have that I now want to fix by designing and building a new dust shoe and adding extra features. But how do you tackle such a project? Since it's so much that I want to add, I wrote down a whole list of features and properties that I want to integrate, and that makes sure that I won't forget any of it during making concepts or 3D models. Next, I took many measurements of the machine and anything that could be a potential problem or point of collision. And I also had to do some minor changes to the machine. First of all, I made sure that this whole assembly moves centered in the gantry, which means that the distance in between here, when it's all the way to this side, is the same as on the other side. Next, I changed out these screws of the side covers with countersink screws to be flush with the surface, because before that, these covers were mounted with these kind of screws, and the head sticks a little bit out and takes away space in between here. And I really needed all the space I could possibly have here. Then I wanted to be able to control the dust collector with the software, and I already covered this in a different video, which works now. Then I wanted to integrate some compressed air to the machine, which means I needed to get my compressed air line to the machine, which I also covered in a different video. And then I had to look for mounting positions where I can mount all the new stuff I want to build. And this doesn't really offer a lot of options, the only really one being these cable clips, and yeah, that's what I'm using.
Next, I took everything to the computer and started with the 3D model of the whole thing. The animation you can see shows the final result, and getting to that was a two-week process with many iterations, and simultaneously I was also sourcing material and components. Very difficult to show that process in a video, but later in the video, during the assembly, you will see all the parts in more detail. But most of the work of this project was done in this step, and I spent most of the time making sure nothing collides with anything and getting tolerances right where it's necessary. After I had all the parts designed, I created toolpaths for all machine parts with which I could start manufacturing everything. Here I'm machining all the holes for the linear rails, for example, and I also machined the functional surfaces for the linear rails. In fact, I machined every functional surface that has to do with the lining in the end. Even though the parts are just plywood, I thought it would be good practice to do that, because if the parts were metal, I would also do that, and that's also how it's done on the machine. Almost every part requires machining from both sides. I usually try to avoid that, but here it wasn't possible. Some parts also require a little more creative clamping. After the wooden parts, there's also a metal part that I needed to machine, which is a stop collet with integrated washer. And finally, some 3D printed parts.
Alright, now that I have all the parts made and bought, it's time for the most exciting part, the assembly. Before adding all the new parts, there is another issue I found and showed in a different video, which is the flex within the spindle mount here. And while I'm taking many parts of the machine apart anyways, I want to fix this as well. What I want to do is to add a connection from this plate to this plate with a set screw.
To install that, I have to remove the spindle.
With only this piece, I can mark the position for a hole and drill a hole for a M5 thread. Back installed, I can use the same drill bit and the hole to mark the matching position on the other plate. And then drill a through hole for M5. This block here will help me drill straight. And then cutting the threads. The set screw now fits through here and can be threaded in. And in between here, there is just enough space for two nuts with washers. So I can clamp this set screw to this piece with the thread with the first nut and washer. And the second one and another nut from behind here, I can clamp to this plate here. And then there's a solid connection. And this then also allows me to fine adjust the tilt of the spindle. But more on that later, now it has to go again.
I quickly built a bigger tabletop for my lifting table to have better access to the machine during assembly and for filming.
First task will probably be the most painful because I need to route two cables and an air hose through all the drag chains. The Y-axis drag chain unfortunately is not quite big enough to put more stuff in it, so I'm replacing that with this one that I've 3D printed. Fortunately, I still can pull all cables out individually without having to remove everything to get the chain off, but still it's quite a pain. Now on my drag chain that I 3D printed, this will be much easier because I included these clips that I can just lift off. Of course I have to work with what I've got here, and I need to route the cables under here and then up through these holes, so there's clearance everywhere and they can properly come out of the cover. But that will be kind of tricky. The air hose just fits through here and that should be somehow possible. I could now route the stepper motor cable through this hole on the other side, but then it needs to go under the belt to the air hose again because both of them will come out of this drain relief at the back of the cover. And that's not ideal. I could also mount it just somewhere here, but there are not many places where I can mount that. I think I have a neat solution now. I replaced the bolt from the ground wire with this longer one, put a lock nut on the end and this nut to clamp it. And this now makes two good spots to put zip ties around. Definitely good enough to hold it in place, and well, it will never move. It just needs to stay there. I did the routing with the zip ties through here off camera because that's just impossible to film and pretty boring. Let's see if it works through its full range of motion. Okay, here's how far it will mechanically go, and the drag chain is good. Let's do the other direction. That looks good as well. The chain seems to be a little too long. Let's try to move one link. Yeah, that seems much better. So far so good. The other drag chain will come later.
Next I drilled a big hole for that strain relief into the red cover. Then I needed to remove the black cover to cut a slot in it. The glue pads it was attached with are the worst to remove. The slot is needed for clearance and gives me easy access to lubricate the Z-axis spindle. I reattach it with some self-adhesive magnetic strips.
Kinda crazy, all this effort so far just for these two things coming out the back here.
Now the real assembly begins, with inserting all the nuts into the hex-shaped holes.
As I mentioned before, every functional surface is machined. The surface where the linear rail gets attached to is of course also machined, and there's also this edge that I have to press it against when I'm screwing it down. That way it's at a defined position. And on the other side there is this gap, and that's on purpose because I don't want this rail to be jammed in the slot. I want it to have play and then be able to press it against this edge. Alright, got both rails attached. Now comes the same for the blocks. They'll mount to the screw together pieces from before, and this machine surface is for the surfaces of the blocks, and this edge will touch both of these surfaces of the blocks, and that will make sure that both of them are mounted straight. So far so good. Let's put them aside for a moment and assemble the drive unit. The heart of that is this more or less complex 3D print, which is motor mount and fixed bearing housing at the same time. So this fits one bearing, then a bushing for the outer race and a bushing for the inner race, another bearing, and this lid clamps everything together. One end of the threaded rod gets the coupler. This I can put through the bearings, and that washer will now contact the inner race. And for the other end I have the stop collet with integrated washer. With the nut I can kind of clamp this together and then secure the stop collet in this clamped position. And now the threaded rod is guided by two fixed bearings. There is no play and it turns really easily. Of course, the fixed bearing block is far from ideal, but for what this is doing, this is more than adequate. Now the motor. And here I have access to clamp the coupler to the motor shaft. Now they turn together. And these two assemblies get screwed together with the embedded nuts in the wood here. This up here is the reference surface for the motor assembly, and the front here just needs to be flush. Now there's this piece that will house the nut, and this will be glued in here with this piece as support. This looks good.
This little pin will trigger the limit switch.
Next comes the part where the brushes and hose attaches. It's split in two and houses two embedded nuts. And these are holes for magnets, making sure all their polarity is the same. And then these halves get glued together. While it dries, let me show you the next part, which is this big 3D printed part where the hose attaches, and that then goes from round to this kind of weird special shape and also angles it about 45 degrees, which in the theory should improve airflow. Then there's also a little bit of a structural part because it connects both the side and bottom piece. And then there's the second piece because I wanted these two to be removable, so the actual hose clamps to here. And then I can easily separate them and use the hose for cleaning the workpiece or the table or whatever. And the way this holds together is also with magnets. Here are 3 holes for them. And in this piece there will be this metal ring glued on top of here, and then it can stick together with the magnets. In hindsight, I'm not quite sure if that was worth it, especially if you take a look at what it took to make this ring. So let me show you. I first made a test ring out of thin MDF, and that fits pretty well. And now I can use this to roughly mark the size of the sheet of metal that I need. Now I've made a 2-part jig to securely hold this on the lathe. This fits in here, and this part of the jig has this ring surface that then gets pressed against the part and securely holds it all around the ring surface while I turn it. There are also 2 alignment pins that make sure that this circular cutout runs concentric with the spindle, and then I drive in 4 screws. I'm pretty close. One more pass. I've now installed the second jig to turn the outside of the ring. This here runs concentric with the spindle. The inner diameter fits perfectly over that. And then I have this piece again with the ring surface, which I use for clamping. With the ring deburred, this should now just drop in place here. Yes, it does. Nice.
I used contact glue to glue it secure and super glue for the magnets.
Now back to the assembly. These side pieces with the sliders will mount to this on this machine surface, like so. But drilling a hole into this edge for a bolt is impossible with a 3-axis CNC. But what I could make is these kind of cutouts, and they now fit half of a T-nut. And then I have a second piece with the same cutouts, and this fits on top and will be glued in place. And now I have a thread in the edge of this piece. Now these square holes with the embedded nuts inside line up with these slots, and the fact that these are slots means there is some adjustability. And from below, there I can screw it on. One on either side, and then there comes the 3D print, and for this magnet that's sticking out here, there's also a cutout in the 3D print. And that fits. Mounting screws here, and on the final assembly I can also screw in here. And then this is all connected and more rigid. So far so good. Now let's mount stuff on the machine. The side pieces just get screwed in here. To ensure that the linear rails don't end up binding, I need to make sure that the mounting surfaces of the blocks here are parallel to each other. For that I have this piece that has parallel edges, and this just gets clamped in between here. And so the rest should also end up parallel. Piece of threaded rod with a nut on the end. This piece has matching slots and a nut from the other side. And then this also has a second alignment purpose, because with only one screw this can just rotate. But it of course needs to be square to the table. So while it's not clamped together, I make sure that it is square to the table, on both sides of course. Then I press that parallel spacer to the black cover and clamp it in this position. And now it's parallel and square to the table, but only if it's rotated so that the spacer touches the cover. And to ensure that this never happens, I lock it in the right position with this 3D printed piece that will hook into the edge of this red cover. Indeed a bit complicated, but with the limited mounting options, I couldn't think of a better solution. Pretty smooth motion so far. Nothing binds and nothing jams. Pretty good. When there are no brushes attached and this is all the way up, the lowest point of the machine is still this red cover. One little issue, since these sides are only connected down here, is that there is some flex. I expected that flex, and that will be fixed on the final assembly when also everything is painted. Then I will screw a connection plate to the back here. That's also why there's a flat spot.
Now it's time to shorten the threaded rod and cut threads in one end.
Now the motor can move it up and down, and if I go all the way down until it hits the end screw, the rails are just still in the blocks. And again, the threaded rod is not the lowest point of the machine, it's still the red cover. The limit switch is screwed to this plate and gets mounted here. And there's lots of room for adjustment. You can hardly see it, but you should hear the click. Okay, next I guess is making the brush. This piece has a bit undersized holes for the magnets in it, and on the other side a channel for the brush. The channel is made to fit that brush perfectly. Only problem are the corners. I'll try to just bend that brush, or else I have to help with the heat gun. Wow, the bending is actually surprisingly easy. Great. Yeah, so much for that. So I tried bending it with the heat gun and it works, but it will be really difficult, and this side quickly got messed up. With this piece I'll try to protect bristles from the heat. And that didn't really work. Let's see if I can at least get it into shape. Not really though. Less heat. That first bit fits. Oh god, that will take forever. Now it's snapped apart again. Maybe I have to simplify this shape and make it only straight sections, or get a different kind of brush that is a lot more flexible. Let's try some more concentrated heat with a soldering iron. And that seems to work. Still have to be careful not to touch the bristles, but now I can bend this radius. This definitely has more success. By far the most difficult part is dealing with that other end of the brush. It's just a nightmare. Definitely still has some spring back, but let's see if I can fit that all the way in. And it actually fits. Unfortunately, the first corner I made is a bit messed up, and I do have enough brush left to do another one, but honestly, who cares? To install the magnets, I removed the brush again because they need to be pressed in, and that's easier without the brush. It needs to stick out 2 millimeters, so I stuck 2 magnets that are 2 millimeters thick next to it, and now just can press down. And that's it. With these magnets sticking out, this will not only hold it up, but also prevent it from moving side to side. And now with the brush. Nice. Now the hose connection. Here will be the only wood screw of this construction, because here I couldn't be quite sure where exactly this piece will end up when I mount it. As you can see, this hole did not end up in the perfect center of this part here, but in the 3D model it does, and I was afraid of exactly that, and that's why I made it a wood screw and drilled a hole during assembly. I've now installed the spindle real quick to check clearances, and as you can see, the space on the side here is about the same as on this side, and that's plenty of space for this to move up and down. And also, if you look at this from the top, this also looks good. But what I'm really interested in, if it works, is when I'm doing a tool change. For that, the brush will move all the way down. Great. the brush will move all the way down and the spindle moves all the way up. And now there is plenty of space to even put the longest bit I have in there. No problem, and I didn't have to remove anything to do a tool change. The hose can stay in place. And this would have been so nice for making all of these parts. There's another brush to install in this slot, and that will create a brush seal between the spindle and this piece. This is a very good fit. I definitely got some practice from the other brush. Later, of course, these bristles need to be shortened. There we go. Let's see if I can fit this. I will shorten the bristles later, but that's all the mechanical parts for now. There is one more part to install, which is this pretty cool air nozzle, but I can't install this until I can move the Z-axis again, so that will be saved for later. The stepper motor cable and 2 wires for the limit switch I'll solder into this connector. I only used one screw to close that, but that's on purpose because the cable that will come out the back of the machine will have the matching connector, also with only one screw, and like this I can screw it to the side and then everything is fixed. The wires just need to be held in place with some zip ties, and then I think that's a nice solution. Probably this length. The matching connector is done, and that's it for the wiring up here. First thing to do now is to route the cable and the hose through the other drag chain, but getting access to that is again a bit difficult. Much better access now. Unfortunately, this drag chain is a bit bigger and has space for the new stuff. Alright, everything is in the drag chain, and if you take a look at this, I couldn't fit any other wire through there even if I wanted. The stepper motor and limit switch cable will already end here. Since I have the 4-axis controller, this port is wired up for the rotary axis. I just use it for a different purpose, and I'll just let the cable come out down here, wire it up to another connector, and then this is already done. But I need to install this solenoid valve for the compressed air. I only could find in 24 volts and the machine only has 48, so I also need to install this 24 volts power supply. And then a relay to control it. And since this will take up more space, I'll also install another one of these thin relays to replace the one that's currently controlling the dust collector. So I can remove one of these and need to add all of this. That'll be fun. Already a dumb issue. These 2 relays are too tall for this box. I would have never anticipated that. But I'm quite lucky here because with the relays mounted exactly here, the parts that's sticking out will end up in this space here. And then it works. Now the valve is wired up and I've set up the machine for testing, just connected the controller and it's already on. And my mouse cursor is on the M7 button, which will control the valve. So now when I click with the mouse, this should also click. And it does. Perfect. I can't really show much of the wiring since it's impossible to properly film in here. And in fact, it's already done. I can show you what is new. So the power supply and red wire from the power supply goes to the Vago clamp. From there gets spread to the 2 coils of the relays. And one goes to the valve. The output of the first relay is connected to 220 volt AC for the dust collector, and the second relay is just connected to the valve. I tried to tidy up in here, but honestly it's still kind of a mess, but good enough for me now. Another important setting is at the stepper motor driver, because at the moment it is set for a bigger motor than I use. My motor is rated for 2 amps and I can take a look at this table and this tells me the right dip switch settings. The other 3 are for the micro stepping, that's set to 1600 at the moment and that's okay.
The solenoid valve I screwed to a plate and then just double-sided taped it to the side of the electrical box.
The air hose I could route together with the cables back here and into the valve. Air supply will come from this manifold here that I screw to this cover with a hose connected to the valve. Last thing to do now before I can do more testing is to wire up this end of the cable for the motor with another one of these plugs. And therefore I got one with terminals and that makes it really easy for troubleshooting if I did anything wrong with the wiring elsewhere. There's also another addition, which is this box back here when the dust collector is plugged in, because before it was directly wired into the machine and used its power to run. And I'm not quite sure, but sometimes I think this caused issues. So now to be on the safe side, this is wired into this box to this relay, and this box has its own power source. So now these two machines are separate. Let's test the two relay functions first. When I press M8, the dust collector should turn on. And it does. And when I press the M7 button, I should get compressed air out of this hose. And I do. Perfect. On the hand wheel, the A-axis. Now, let's see if it moves. It does. Nice. And now with a bit more speed. Seeing all of this working for the first time on the first try is really nice. I've set it up so that this axis has its 0 position when the brushes touch the spoil board. And when I now have a workpiece that's, for example, 17 millimeters thick, I just set this axis to this thickness. And there you go. When it's time to flatten the whole spoil board, I do that with a macro and take off like 1 millimeter of the whole surface. When it's finished, it will also set the new 0 position 1 millimeter further down, so everything still works and it's all automatic. This also means that this axis can move further down without the brushes, but that's only necessary when the spoil board gets thinner. I've also designed it that when it's at its lowest position, that all the components are also maxed out. So the linear rails right here, and the length of threaded rod ends right here. And when it's at its highest position with the brush attached, there's still no collision. There's about 0.5 millimeter of a gap there. There's also no collision on this end and on this end. Next now comes the hose. When I have a hose like this, where I also use it to kind of clean up a workpiece or something, I hate these pointy ends of these hoses. Previously I had this much shorter and kind of clamped it underneath the hose clamp, but this time, since I printed this anyways, I integrated a hole for that where I can fit this in. And with that, it's really out of the way and I can't hurt myself on it. Up here I also upgraded this adapter, which only was a press fit and sometimes came loose and fell down, to this here, which I 3D printed, and it has a hose clamp and this can be clamped on. What you can also see up there is this wire, which is a ground wire, and I connect this to the coil of the hose because during use it always gets a little bit statically charged, and when I then go to it to clean something up with it, I always get a tiny shock, nothing dangerous, just uncomfortable, but now not any longer. Last part to install now, which I'm pretty excited about, is this nozzle for the compressed air. It's a wonderful example for good use of a 3D printer because this is all one piece, has internal piping, directional nozzles printed in threads for this connector, mounting positions, stiffening, and all while being ultra compact. And this actually mounts to the holes where the old dust tube was attached, so these holes still have a good use. This is also designed to be just above this collet, about 0.5 millimeter, and these nozzles are directed to about the average bit length that I'm using. No special fastening for the hose, it's just organized together with the other cables. And now this works. The amount of air coming out of there is not that much, it's just coming out fast. In fact, it's only 0.5 bar on this gauge. And for the purpose of it, that's plenty for getting the dust airborne, so it's easier to suck it out of the air for the dust collector and to get the dust out of deep grooves, especially the ones that are cut with a down cutting bit.
The new parts of course also get some paint that matches the machine. While the paint is drying, I trim the spindle. One direction I have to do with shims, the other direction I can now do with the set screw. I explained the whole trimming in more detail in another video. Before painting, I taped all the important surfaces, and now comes the satisfying moment of removing the tape again. But I didn't film the final assembly.
Alright, now with some color and finish, it's done. Let's try it out and cut something.
I start with flattening the whole spoil board. As you can see, the dust gets picked up very well.
Alright, it's flat again, and there is no dust laying on the table. Some is here, but that's unavoidable because that comes from when the brush overlaps here slightly and not making full contact with the surface, and yeah, then this always happens. But so far I'm pretty happy. Next I want to cut a bit storage thing for a drawer.
Here you can see how I programmed the behavior of the new parts during a tool change.
Alright, that came out great and perfectly dust-free. Some dust around the part, which came from cutting the pocket, because there was a gap between the surface being cut and the bristles. So there's some dust that can escape, but the part itself is basically dust-free. Now I have a nicely organized drawer with all the accessories and bits that I usually use. Nice and labeled with tool numbers and sizes for the reducer collets. What I especially like is that I can very easily grab any bit by its shank and don't have to touch the cutting edges. These are V-slots, which means they fit any bit diameter. I don't understand why so many people like to store their bits upright like this and you have to touch them by the cutting edges. That's pretty stupid to me. On the side of the boxes I glued some pieces of wire into the grid, which now indexes all the boxes and keeps them in place. Alright, I think it's time to give this a wrap up. In the beginning of the video I mentioned that I see this whole thing as an engineering project on easy mode. Many of you now probably think, what the hell is he talking about? And indeed, making this had its difficulties and was by no means straightforward. But what made it a lot simpler is I had control over everything. I decided what it can do, how it should look, and how much it costs. And the other thing for an engineering project now is I don't have to market this and have to make it mass producible. And that is a big deal. See, as good as it works and as cool as it is very expensive. I easily spent 400 euros on parts and material for this. No manufacturer would include such a unit on a hobby class machine like this. The cost far outweighs the benefits, and I only had to build this single unit and can live with it. And I'm very happy with it. The big deal for me was the learning experience and the fun I had while making this. I mean, designing it, making the parts, assembling them, seeing it all come together and seeing it work for the first time was just a blast, and I really enjoyed that. And I also learned a lot, especially how time-consuming some parts could be. Oh god, making tool paths that make good parts took so long. But well, here we are now with this finished result that I'm very happy with. As I said, I really enjoyed this whole project. And I hope you did too. Follow me along during the video. And if you want to support me with a project like this, a good way is to do that through Patreon. You can join me there. And in fact, your support through that enables me to also tackle more expensive projects like this one with ease. So I guess then I see you in the next video. Finally he stops talking. Yeah, I like the video, subscribe to the channel, ring the bell, whatever. Come to an end.
Hey guys, welcome back. So today we're working on this 4,000 watt Coleman Powermate. It is powered by an 8-horse Briggs flathead engine and looks to be in excellent condition. There is minimal rust. It is complete. There are no missing parts. And from the looks of the exhaust, I would say this has seen very little action. The paint still has a really nice shine. Unfortunately, I don't know really anything about the history on this machine. My friend Jason dropped this off. He was hired to clean out a garage, and this was one of the items in the garage. The people who hired him also had no idea of the run status of it, but from the looks, I would say this was extremely well cared for and is going to take very little effort to get up and running again. Now, I haven't done much to it other than pull it over. The engine spins without issue and it has compression. And I also took a look in the tank. The tank, thankfully, is not rusted out, but there is some old fuel in there. It is well past its prime, so we are going to have to clean that out. And according to the date code, this was made October 12th, 1987. So this is a 37-year-old machine. And from the looks of it, a very well cared for one. So yeah, let me get you set up a little bit better and get going on this. Let's check the oil real quick. Make sure we have some. And I am not seeing any. It should be filled up right to the last thread. I think it's empty. Yeah, I'm not seeing anything in there. You know, potentially there could be a little bit at the bottom, but it's well below the safe zone. So we do need to add oil. I'm thinking before we do that, let's just pull the plug, make sure every last bit is out, and then we'll start fresh. Yeah, it's a little bit. So this engine should take 1100 milliliters, which is essentially filled right to the top of oil. And this is all that came out. You know, I'm thinking this is probably about 300, maybe 400 milliliters. So we were significantly down on oil. And despite this machine looking so new, you know, if this was run much longer, it would have blown the engine for sure. It makes me wonder why we're so low on oil. You know, potentially it was underfilled, or we have an engine that burns oil. And I'm thinking we have an engine that burns oil. This is actually the third 4,000 watt power mate of this vintage I have worked on. And I use the term worked on loosely because the first two came in with holes in the side of the block. They had run out of oil, so I just ended up harvesting their generators and stuck them up on a shelf. So if for some reason this generator doesn't work, we do have a plan B and a plan C. But all I can say is if you have an 8-horse Briggs flathead of this vintage, you might want to check the oil because these do not have an oil sensor, and clearly they have a problem consuming oil. So let's get this one filled up and then we'll move on. We'll get the old fuel drained out. And I think we'll do the easy thing. We'll just put some new fresh fuel in and we'll try to start it. I'm going to start by draining the tank, and you can tell this has not been messed with. This fuel clamp, it is painted green like the rest of the engine, so this has never been removed. So the fuel line may not play nice here depending upon how petrified it is, and it does actually feel absolutely petrified. So I'm actually going to cut that off and we'll just put a new line in its place. And cutting it off is really the only option here. You know, when the fuel line becomes petrified, they don't come off the barb very well because it has to flex to come off the barb. And if it's petrified, you're not going to get any movement. Like right now, I'm pulling down on that line, and you can see it is just rock solid. go. And thankfully, not a whole lot of fuel was in that tank. You know, the majority of it did come out, but it is still damp in there and just a tiny bit of debris. So I'm going to mop out what's left just to make sure that tank is spotless. Let's try to get this off without cutting it. You know, sometimes the barb on the carbs, it is made out of plastic, and the razor blade can cut it up pretty bad. So let's just pull the needle out. You know, if there's any fuel in here, we can drain it. You know, potentially it was stored dry, and the carb might be in good shape. And yeah, the threads look nice and clean. There's no corrosion and nothing drained out. So this carb potentially doesn't need to be cleaned. So let's add a new fuel line. We'll add some fresh fuel. Throttle plate's not stuck, so we'll pull it over a few times, see if it shows any signs of life. So we'll just cut up a new line using the old one as the template. So let's turn the fuel valve on. We'll give it a minute for the carb to fill up. Make sure the needle and seat work. And if they do, we'll try to start it. Well, it's been a few minutes and nothing is leaking out of that carburetor. So I'm going to get a light plugged in and turned on. We'll turn the choke on and see what we get. Gotta love these old Briggs. You know, I gave it a good 4 or 5 pulls with the choke on, and it was doing nothing, but I could smell fuel. So I turned the choke off, gave it maybe 2 more pulls, and this thing came right to life. Now, it was running really rich, so I did have to turn the main jet in a bit to get the engine speed to pick up. And then I fine-tuned it, and this thing ran absolutely perfect. You know, the engine sounded great, and we're making power. So this is going to be a quick video. I know, right? But it doesn't really need much more than a load test. You know, I did take a quick look at the filter. It's not in great shape, so we might get a new one of those ordered up. But I'm thinking, you know, for once, I may not have to clean that carb. You know, someone stored it dry. Someone obviously took care of this machine. So I say we just get a new filter on and get this thing outside, and we'll put it to the test. So it's a day later, and we got a new air filter from Amazon as well as a plug. So we'll get those installed real quick. This is probably the rustiest part of the machine right here. So I might take a second and just wire wheel that, try to get some of that rust out of there. So this was a tiny little Champion CJ8 plug that came out of there. You can see it's well used, and I don't think that was the right plug. You know, I did a little bit of research on this engine, and what I saw was that an RJ19LM is what should have been in there. So we'll double check the gap real quick. It should be right about 30 thousandths, and we're actually a little bit over at 34. So let's try to close that gap. And I overshot. We're now at 26, so yeah, it doesn't have to be precise. Actually, 26 is probably a little better than where it was. There we go. Right at 30 thousandths. In theory, this should be ready for testing. You know, all we need to do is get this outside, let the engine warm up. You know, I do need to fine tune the carburetor, and at that point, we should be able to load test this. That said, it's only Tuesday, and I do my load testing on the weekends, so we have a few days to kill. And since this video is so short, I'm thinking maybe we should get a jump start on the next video. You know, I recently did a video on a Champion dual fuel generator that dropped a valve and caused a lot of engine damage. You know, my hope was I could rebuild this engine, but being that it's a slightly odd size, you know, I couldn't really find parts for it on eBay. And I checked the Champion website. Some of the parts were there, some of them weren't. And even the ones that were there, the cost was kind of borderline. I wasn't sure if it made sense to try to rebuild this. So, I set this aside and instead repowered that generator with a Honda GX390. and was a little bit disappointed because that engine fell a little bit short on horsepower, and I also found out it has a bad oil sensor. Anyway, as soon as that video aired, a Champion dealer reached out and offered to help. He said often dealers have access to parts that the public don't, so I gave him the list of parts I needed, and within a few days he had those parts in hand, sent them to me at cost, and well, here they are. So I need to prep the block for a rebuild. But before I do that, let's get the box open and just make sure we have everything we need. That is the new cylinder head. We will take a look at that in a minute. New connecting rod. The original one actually survived. It was the dipper that broke off, so we needed a new one of those. The head gasket. Actually got two of those. And here is our new piston. No piston rings, but those I did order, so hopefully they're in one of the other boxes. Oh yeah, this giant box has a new wrist pin, some circlips, keepers, two new valves. I got a new intake and exhaust, and the set of rings. And then in here should just be the cylinder head. And yeah, it is a bare head. And there's actually no valve stem seal, so that I think is an oversight on my part. I don't think I ordered one of those. I do have some for Honda GX390 and clone, so I'm hoping that this one is close enough to a Honda clone. So let me grab one of those seals. Actually, before I do that, let's take the old head off. We'll take a look at what the old seal looks like, and then we'll pull out the Honda clones that I have, and hopefully they're the same.